Hello, welcome to Ekidel. My name is Justice Umoka. I am your instructor. Today, we will be learning how to design a tie beam for a concrete building. Okay, looking at this right now, this is a floor plan of this model where I am using AutoCAD 2022 and I am using Prota Structure 2018. Now, looking at this right now, this is a floor plan of this structural design right here. In my last video, we did a video on how to design a concrete building just like this. So in my last video, we did the design of this concrete building from start to finish. You can check in my previous video, and if you don't see that, you can check on the link below for that. So but for today, we will be designing the tie beam to carry these ground walls right here, these ground floor walls. So as you can see right now, this is a tie beam right here. If I maximize this right now, you can see that we have successfully designed a tie beam which is supporting this column, this column and this footing base right here, and also carrying the wall load on this ground floor. I can see that this is our tie beam, and this is our first floor beam, and this is our roof beam. So we have successfully designed this. The reason why we did this tie beam lesson for you guys is because of the comments that we had when we posted just this video on how to design concrete building from start to finish. Like if you go to my YouTube channel right here, Ekidel, if you open your YouTube and just type Ekidel, you will see that we have successfully this is the video of that of this building right here. So this is the video of this building. Let the app just go off. I can see that this is the video. If I forward it right here, you can see the video of that. So this is the video of this building right here, and you can also see this plan, this floor plan right here, which is the also this floor plan here. So we have already done design for this building, but what was required was that we had a lot of comments from you can see the comments that we have. So we had comment from Stan Tablizo. We had a comment from Mr. Stan Tablizo that it would be nice. Okay, from here he said, Ekidel, can we put also footing tie beam to support the walls? And then we now replied and promised that okay, I will do that in my next video. So that comment was what prompted us to provide a tie beam for this building right here. You can see that this was our previous one, just footing base. There was no tie beam, but right now we have successfully provided tie beam for that. So we have answered the comments of our friend Saba Tablizo. So we have answered the comments of providing tie beam for this building. So in this video, you will learn how to model a building with tie beam and also design the tie beam. So I would say you should sit back while we get started. Thank you. Okay, so we will be creating a footing tie beam for this building right here. As you all know, if you are a full subscriber of Ekidel, you will know that in our last video we did a design of this concrete building from start to finish. So along the line we begin to get comments that it would be nice if we design also for a tie beam for this building that would be able to support the walls. So we promised to make a video and to teach you guys how to design a concrete tie beam for a concrete building. So Today we'll be showing you how to design a concrete tie beam for a concrete building. Now the tie beam will be connecting these columns together, which will bring firmness and stability to the columns, and also, but the main purpose is to carry the walls which will be sitting on this ground floor. So let's get started today on how to create our tie beam right here in Prota Structure. So to do that, we go to our floor plan model. But before then, let me take you back to the 3D view to show you that this building was already designed in our last video. So if I go to check on our design status right here, you will see that this building has already been designed. So we want to add a tie beam right now to this building, so that it can be able to support the walls that is coming on this ground floor area. So to begin that right now, to add the tie beam to this already designed building right here, we will just go back and go off from this model, then go to the plan view and then click on plan. Now we go back and click on story 1, and then we will now begin our tie beam modeling from here. Now to begin the tie beam, we click on beam here. Now this is, you should really pay attention on what I'm going to do here right now, because as you can see, we already have a beam right here, and you know Protastructure will not allow you to insert any other beam again since you already have a beam right here. So what I will do is that I'll begin to play with the concrete member elevations. So you have to play with the concrete member level, and to do that right now, for you to be able to insert a beam in Protastructure on top another beam, you must have to change the level of that beam. The two of the beam you are trying to insert must not be at the same level, else Protastructure will not accept it. So to create our tie beam, which also have the same properties with this floor beam, we have to change the level of the tie beam. Of course, the tie beam is meant to be at the foundation level and not at this first floor level. So to do that right now, we will click on this 3D. The first thing you do is to click on this 3D right here, this 3D tab. When you click on this, you now have to change the level here. Now, knowing that this level right now is at the level of 3.6 meters, as you can see it right there. This is a level of 3.6 meters, which from that level, the DPC level is 0.45 meters. So the actual level for this story 1 height is 3.15 meters. So with that now, and we want to impute our tie beam to be directly, we want our tie beam to be directly on this face here, to be directly on top of this footing. So to do that right now, knowing that from this level to this level is, to this level is 315 meters if you subtract this DPC level. So to input our tie beam right now, we go back to our plan view, and then starting from here, we have to input this level. Let's start with 3 meters. Now you have to change the level of the beam you are about to insert, which is the footing tie beam, to, let's start with 3 meters. Since this is 3.6 meters, let's start with 3 meters, and since we are going downward, we will input minus. So we go and say minus 3,000. Okay, let's start with 800, then we can do proper editing from there. Then minus 2,800. Then we can now click on this point to insert 1 point and this point. Now you can see that we have already run building design on this model. So it's trying to tell us that this following analysis, the following analysis result will be invalid, because we want to tamper with the model. So we'll just say yes. So we have now inserted another beam, as you can see there, beam 21. Then we click here again to insert again. Now if you go to our 3D view right now, you can see what we have achieved right here. You can see that we have successfully created our tie beam, but our tie beam is trying to enter our footing. So we will just click on escape and begin to edit the level from here. I'll just close this, begin to edit the level from here. So I'll click on this right now, right click and say properties. Then I will now click on this 3D to change the level. Now looking at this right now, you can see what is happening here. So let's take minus 2600 to see, and minus 2600 and say updates. Okay, you can see that now the tie beam is a bit far away from this level. So we can now click on escape. So you can now see the tie beam is a bit has a bit distance from this our footing, from this our part footing. So therefore we have known that our tie beam level is minus 2600 millimeter. So we also edit this one too, because all the tie beam must have the same level. So we click on this level and say minus 2600 and minus 2600, sorry, and then we'll say updates. You can see that. So click on close this one, and then right click and okay. So you can now see what that we have created the tie beam for this right now. Okay, so we do the same for these other ones here to create other tie beams for this. So we go back to story 1 and then right click and say plan view. So you can see that we have already created a tie beam for this. Now we want to create other tie beams for all other places where our walls will be passing. So we continue, we click on the beam icon, knowing that we have already imputed this level, so this level now will now remain constant. Then also we want our tie beam depth. We didn't touch the tie beam depth, so let's just go back to our 3D view to edit. We want our tie beam depth to be at least 450 millimeter, not 300, that as it is here. So we right click and say properties, and then we go to our depth and change our depth to be 450 millimeter, and then we say updates. Now you can see again that it's coming downward, so therefore we will have to go and change the level right now to be minus 2400 and then minus 2400, sorry, and then we'll click updates. And then now you can now see, we can now click on close, escape, do the same thing for this level 2 to change, because all your tie beam must have the same level. So to 450 millimeter, which is the depth of the tie beam, and then the level is minus 2400 millimeter. The same thing happens here, minus 2400 millimeter, and then we'll click on updates. Okay, so we have now successfully created the tie beam, as you can see it right now, knowing that our level is now 2400 and no longer 2600, because we now have our tie beam depth to be 450 millimeter. Okay, so we can now click on escape and then go back to our plan view to insert on the rest areas where our beam will pass, where our walls will pass, sorry. So click back on our beam icon, knowing that we now have our default depth to be 450 millimeter, and our level, our default right now becomes minus 2400 millimeter. So we will now click, we have already inserted our tie beam here, so we can now click on this right now to start inserting our tie beams. So we click to this next. You can now see that there is no obstruction or any warning telling us that a beam is already here. The reason is because we changed the level right here, we changed the elevation level right here. So we also click to impute our other beams. We are dealing, okay, you can see a new beam is crossing. Okay, let's just say no. Okay, it's here because of this, a new beam, yeah, just say no, because it's telling you that there's a beam crossing. So for you to input a beam, do you want it to be supported by this? So just say yes. Then we'll do again here. The warning will still come out on this one because of this beam here, because of this beam. So we'll just say no. Then we'll go again and click. Okay, now we have already inserted here, so just click on escape and let's see what we have achieved right now. Click on 3D view to see. Now you can now see that we have successfully created all our external tie beams. The next thing that I will do is to create our internal tie beams, which will be along this this area, which is the internal tie beams, and also create a tie beam for these two footing base here. So we'll go again back to our 3D view. Normally we can work on this place, but let me just go to our 3D view, to our plan view to work from there. So we have successfully created tie beam for these external ones. Let's now create again for these ones. So click on this point. Sorry, we didn't select we click on this beam, then click on this point, and then click on this. Then also click on these two and on this. If we check our 3D view to see what we have achieved, you can see that we have successfully created tie beam for this area. So you can see that we have successfully created tie beam for this area, as you can see it right here. Okay, we go back to our plan view. Our plan view to insert to now start the internal tie beam. So you click on escape. Now again, you go back to your beam again, still having the same properties: 230 millimeter, which is the width of the beam, and 450 millimeter, which is the depth of the beam, and also the level at 3D here is minus 2400 millimeter at the right hand side and at the left hand side, which is the I and J. So we now begin our internal ground beam. So to do this right now, we have to take the properties of this beam, because consider that this beam is not inserted, this grid line is not passing through this middle. So we click on escape, take the properties of this beam before we insert, and then we cannot change this level to be to a minus 2400, minus 2400. Don't click on update, else if you click on update, it will change this one automatically. The main reason why we do this is to insert a new beam. So once you change this level, you have to now click from this point and click on this other point, then click on escape, then go and check it out on 3D view to see what you have got. You can now see what we have got right now. The next thing again right now to do is to go back to our plan view to begin the next internal tie beam. So with this right now, we will have to change these properties, because you can see that this grid line for this beam is passing at the middle. So we click on escape and then click on this beam to take its properties. The only thing we will change right here is to impute. We already have the same similar depth, which is 450, and width to 230. So we'll just change the level, else Prota will not accept it. It will tell you that another beam is already inserted at that level. So to minus 2400 for the tie beam level, and minus 2400 for the tie beam level. And then we can now click on these points to this point. We have a colon here, and to this point. Okay, because of this beam that is crossing here, that's why I seen this error. That's why I seen this warning. If you say yes, it will have to divide. If you say yes, it will divide this beam you're trying to insert directly on this point. But we want to run this beam from this point to this point, and so we will just say no. Okay, so now click on escape. We do the same thing for these. They have the same properties. The grid line is passing at the middle, so we'll click on this. We'll click on this. Okay, also, and we also click to insert this. They have the same properties. Click on this and then click on this. We'll say no. Then we'll click on this also. Then we also insert this. They have the same properties. We'll click on this and then click on this. Then we can now click on this to remove this cantilever, as you can see, because we inserted this one first. We are meant to insert this beam first, so that we can now insert this beam to carry to tie itself on this beam. So we will now click on this beam to remove this cantilever. We'll just go here and then say supported. So if we go to our 3D view right now, you can see that we have successfully created our our tie beam. You can see that we have created our tie beam successfully. If you click on story 00, you can see that we have successfully created our tie beam. So this is our tie beam. Now the next thing right now is to add wall load to this beam, because the reason why we created this wall load is for two reasons. One, to be able to support the wall load or the walls of that will be coming on this ground floor, and also to be able to support these columns, to be able to tie the columns together. The reason why, if you see most of American building and most countries that have earthquake, you see that even if they are designing for the least bungalow, they must include tie beam. Most people see it as a waste of money, but that's not true. The reason why they are doing that is to bring firmness, because earthquake causes vibration, so they want to tie the whole column together, so that at the sense of earthquake, at least, even if it will cause damage, because you cannot design perfectly that your building will not be affected if there is adverse earthquake. But the reason why we are designing for earthquake is at least, even if there is an earthquake effect, it will not have much effect on the building. You can see that. So that's why most of American buildings and most countries that have earthquake, they always design for tie beam. But most countries that don't have earthquake, mostly in Africa, they don't need to put tie beams, although it is good to put a tie beam, because it will be able to carry your walls. If you don't put tie beams, you see that any slight vibration, it might not be from earthquake, you see that your walls begin to have cracks. So that's why it's advised to also put tie beam, not minding the cost, although we also design for cost, to be at least let your building should not be more expensive. But in our area, we are looking for safety and also at least economy. So this is how we have successfully created our tie beam, as you can see it right here. The next thing we'll do right now is to impute our wall loads. So to do that right now, we will go to story 1. We go to story 1 and then go to our plan view. Okay, we can do that right here. We'll just copy this beam. We'll just click on this beam right now. You can see that this beam already have a wall load. So we click on one of these wall load. This ash here, this gray color here means that this beam is having a wall load. So we'll just click on one of these hashed area, which is the wall load. You can see that the beam have a wall load. Right click and say copy beam wall load. Then we can now zoom up right here. Click on this plane beam. Right click and say paste copied beam wall load. Yeah, I'll say yes. Now you can see that the height is different. So knowing that this from this point to this point is 3 meters, and we have already moved, this level is 2.4, so invariably we have already moved 600. So we have to edit the height of this wall load. So just click on this tie beam right now that you pasted the wall load. Right click and say edit beam wall load. So coming here, we will change the depth from this 3 meters right now to removing 600 from there. We have, let's say, 2,400, and then we say okay. You say the height is less than the expected value. Check the wall data. It's okay. We go. Okay, I know what happened. We imputed 2,400, and this is in meters, so we are meant to put 2.4. Sorry, 2.4. Yeah. So we now click on updates. Okay, so you can now see that we now have a tie beam having this level of wall. So we have simply inserted the wall load on this tie beam. If you click on outside right now or escape, you can see that you have your tie beam. You can have your wall sitting on your tie beam. So you can click on this place now to copy this wall load and paste on all other places which you have wall, which on this area, on this case, we have wall. So just not to cause issue for ourselves, let's first of all paste this wall load on the internal beams. Else, if we paste on this place, we will not be able to have access to these internal beams. So we'll click on this one right now, and right click and say paste we have pasted it. We click again and say copy, although it's already on auto copy. So doing this right now, we zoom into the internal area. So we can't be pasting it one by one. So to do that, we have to click all the internal beams at once, holding our control key. So if you hold your control key, then begin to click on all the internal beams, so you can be able to insert it at once. So click on this, and on this. Okay, I think we're done with our internal beams. Okay, this one also should be clicked. Okay, then we can now right click and say paste copied beam wall load. Okay, you can see that we have that. Then now begin to insert on this area to input wall load on this. We click, holding our control key to paste all at once, else you have to paste it one by one, which will take time. And let's see. Okay, this one, click and click and click, and then right click and say paste. Okay, so you have now seen, if you click outside or escape, you can see that we have now created our type beam and also our wall load on this. The next thing right now to do is to run analysis right now on this building afresh, because this type beam that we inserted, they have to disturb the other design that we just performed. Like I said before, this building have already been designed before from start to finish. So if in case you missed the video, you can check the link in this video description to see the starting of this design, so you can follow up this lesson. But if you have watched it before, you can just start from here and then begin to begin this new project on this lesson. So we can now click on our plan view, go into this, click on plan view. To run this analysis right now, we can now click on, first of all save, then we can now click on analysis, building analysis, and then we click on we go and click on analysis. We have already done the loading. Like I said before, check on our previous and check on the link below to see the starting of this design, which is the part 1. This is just a modification to add a tie beam to this structure, just as we had a lot of comments that we should put tie beam. So we click on analysis, and then we check this design for beam, design for column, and then we'll click on. Okay, let's check our model check first. We check on building model check to see if there is any clashing or any overlapping of beam. You can see that there is no overlapping, so you can see that you applying that level on that beam to drop the type beam didn't cause anything like overlapping. Prota understands that you are trying to design a type beam, so just say close, and then we'll click on start analysis and design. So right now it's trying to do the building analysis, and now it's trying to do the column design, and it's almost done. Now we have entered the beam reinforcement design, which is almost done. It's almost done. So you can check on our video below to see other. Okay, you can now click on OK. That's just a minor error. Click on OK and then click on close. Then we'll go and check on our design status. So let's close this and check our design status to see which member passed and which member failed design. So we click on design status right here and then click on OK. Then to see our tie beam, if they all passed design, or to see if they are sufficient to carry the load, which is on the column, which is on the beam, we click on this and click on 3D view. So you can now see that our tie beams, they are all okay. They all passed design. You can see that right now. You can see if you use Prota very well, you can know that green means that your design have passed. But like I said before, even at that, you will have to check your we have to check this beam one by one to see the kind of reinforcement that Prota Structure software used to design this building, this tie beam, if it is the kind of reinforcement that we want. Because you as an engineer, you must not depend on any design software at all. You must have to give it your own specification on the kind of reinforcement and the kind of size of reinforcement that you want. the design to give you in your detailing. So we have to click on the beam right now to start checking on our tie beam reinforcement. So we'll click on this beam, right click, and then we'll click on beam section design. So right now you can see that it passed with two number of Y16, which simply means 2 diameter Y16. So you can see that it's okay. If you're not okay with it, you can click to add. Maybe you maybe want to add 3 number down and 3 number down, but for this case it is okay, because you can see our you can see this place, which is called the area of reinforcement. You can see that they are okay. They are, at least we're having 325, 327 here and 350 right around this area, so it's okay. At least you can begin to add if maybe you are having up to, let me say, 30 or 50. You can know that you have to add, because any slight increase in load we fade that beam. But on this area right now you can see that it is 350 and this is 327.46 kilonewton per millimeter square. So it's okay. So you can now click on OK. So this beam now is okay. So you must check on all your beams. We check on this again. Once you click on this, it will check for all this length. That's the beauty of checking your beams on this 3D area. So you click on this and check this beam. Okay, this gave us 2 up, 2 down, 2 number of reinforcement up and 2 down. So this is okay. I click on OK. I go again to next again to check on our tie beam to see what this beam gives us. Okay, 2 number of diameter 16 down, 2 also up and down, 2 up, 2 down. This okay. We click on OK. Then we go to check on this one. Right click and say beam section design. This gives us 2 up, 2 down, 2 top, 2 down. Okay, this okay. We click on OK. Then also we click on this to check on this one. Like I said before, you must check your beam. You must check your concrete members one after the other, which is the beam, the column, one after the other. You must check them. I'll click on. We check this to see the kind of reinforcement, because most times this software Prota can give you this as Y32 at 32 diameter of reinforcement. And if you didn't check, you just go and print and you see that you just be messed up. So you have to check. You have to check. So let's use two number of Y16. So click on that to check this again. I click and say beam section design. This is also okay. We click on OK. Then we'll go over to our internal beams. We cannot have access because we already have a wall load here, which is blocking the access for us to access our internal beam. So we will have to go down. We just rotate to look this building from under to check our internal beam. So you can see how stressful I am going to check the beam one after the other. That shows you how important it is. It might look stressful, but it's very important to know the kind of reinforcement that the software gave you for your beam designs or for your concrete member designs. So you go on this to check this. No, this is the moment. So go right click and say this. Okay, this is okay. 2 top, 2 down, 2 top, 2 down is okay with me, and the spacing of the links is also okay. I click. We have checked for these two. Next thing again to check for this one here. Let's check for this. Right click and say be this. Now this is giving me 155 and 166. It simply means that this beam is under stress based on the walls. So I can increase this to 3 number of Y16 down and 2 top. You can now see we have 370 left and right and 356 at this at the span. So click on OK. So it's good to check your beam one after the other. Even if it's stressful, it's good. As a good engineer, you have to know the kind of reinforcement a software is using to design your building or your structure. Okay, so this is okay for me. So you don't depend on the software totally. So okay, so this is our last beam to check. We'll check this, and this is okay, and this okay. So you can see that we have successfully designed our tie beam right here in Prota Structure. So this is how to design our tie beam. The next video or the next lesson we'll be doing from the comments we have is to design a strip foundation and also a raft foundation. So we will also design a raft foundation for this building. So I'll urge you to subscribe and also share this, share my channel, share the video to your friends so that they can also learn how to design, how to use Prota Structure for to design concrete building. So thank you and welcome and God bless for participating in this lesson.